Hello friends, this is the third video on chapter number 10. In my first two videos, I had explained on the exercise 10.1. Now in this video, I will first explain the various forms of a line, and all the solved examples. And in the second part for the exercise 10.2, there will be the full exercise 10.2. I will explain all the details in a very simple language so that you can understand all the basic concept, all examples. Now let us start. Various forms of the equation of a line. Horizontal and vertical lines. See this, the axis x-axis and the y-axis. Here the first line, it's a parallel to x-axis, at a distance a, and therefore its equation is y is equals to a. And the second line, it is parallel to again x-axis, below the x-axis at a distance a, but its equation is minus a. Therefore, whenever a line is a parallel to x-axis, then its equation is of the form y is equals to question mark. It means that when a line is parallel to x-axis and intersect y-axis, and suppose that its intersecting point is 0 and 2, then what is the equation of that line? The equation of that line is y is equals to 2. Suppose here is a line, again it is a parallel to y-axis, it intersect at the point 0, 4, and therefore again its equation is y is equals to 4. If I draw the line, another line which is the below x-axis, and it intersect at the point 0, minus 2, and therefore its equation is y is equals to minus 2. What you have to remember, when a line is parallel to x-axis, then its equations are always y is equals to question mark means what? Where it intersect the y-axis. Here the line intersect y-axis, it's a 4, and therefore its equation is y is equals to 4. Here it intersect at 0, 2, y coordinate is 2, and therefore its equation is y is equals to 2. Here it intersect at the point 0, minus 2, and therefore its equation is y is equals to minus 2. And therefore, in general, whenever a line intersect y-axis at 0 at the point, suppose this point is 0, a, then its equation is y is equals to a. It intersect at the point 0, minus a, therefore its equation is y is equals to minus a. These are the lines which are parallel to x-axis. Now here next we'll see the lines are parallel to y-axis. See this here. Here the line L, these two lines are parallel to y-axis. Whenever it is a parallel to y-axis, then its equation is x is equals to question mark, where it intersect. Now suppose this line intersect at the point 2, 0, then its equation is x is equals to 2. Suppose the line intersect here at the point 3, 0, and therefore its equation is x is equals to 3 in this way. Next here, the line intersect at this point. It intersect, the point is, it is a minus 2, 0, and therefore the equation of that line is x is equals to minus 2. In this way, whenever a line is a parallel to y-axis, at what point it intersect, that is the equation of a line. In general, suppose that the line intersect at the point Suppose here 0, b, and therefore its equation is x is equals to b. Here it intersects at the point 0 minus b, and therefore its equation is minus b. Then what you have to remember, whenever line is parallel to y-axis, then its equation is x is equals to. Whenever the line is parallel to x-axis, then its equation is y is equals to. This you have to remember. These are horizontal and the vertical lines which are parallel to the coordinate axis. Now the next step. The example, find the equation of the lines parallel to x-axis. Okay, parallel to x-axis and the y-axis passing through the point. Here is a point -2 and 3. Now first we find the equation of a line which is a parallel to x-axis. When line is parallel to x-axis and passes through the point, then its equation is y is equals to. Okay, y is equals to. What is the y coordinate for this point? Y is 3. Whenever we want to find out the equation of a line which is parallel to y-axis, then its equation is x is equals to. X is equals to, then what is the x coordinate for this point? Is -2, and therefore here the equations of the lines, that is x is equals to, sorry, y is equals to 3, and another is x is equals to -2. These are the equations of the lines parallel to the coordinate axis. Okay, now the next, slope point form, very important form. Suppose that point P x0 is a fixed point on non-vertical line L. It is not parallel to any axis. Therefore, we say that it is a non-vertical line L. It is not the parallel to y-axis. Suppose that its a slope is m. Okay, the slope of the line is m, and x0, y0 is the fixed point. We know that point. We know this slope, and we want to find out the equation of that line. Then we say that P, X, Y be an arbitrary point on L. It means that any point on that line. Suppose that here we have taken it's a point is any point. We know this point. We know the slope of that line. Okay. Then what is the equation of that line? The equation of that line is, that is m is equals to. Suppose I want to find out the slope of this line. Then what is the slope of any line when we know the 2 points of that line? That is the difference of y coordinate upon difference of x coordinate. Means what? Y minus y0 upon x minus x0. Now simplify this. Then what you will get? Y minus y0. This term will multiply to m, and you will get y minus y0 is equals to m in bracket x minus x0. This is the slope point form. It is called the slope point form. That is, we must know the point on the line. We must know the slope of a line. Then we can find out the equation of a line. Okay. Now the next is, that's a problem. Find the equation of the line passes through the point -2, 3 with the slope is -4. It's very easy question. See this here. It's a solution. Here we know the slope as well as the point. Okay. Then what is that point P, x, y? This point P, x0, y0 is -2, 3. And what is the slope? M is equals to -4. And therefore, equation of a line. Okay. Equation of line with, here we know the slope and the point. Therefore, equation of the line with slope point form. slope point form. What is that slope point form? Y minus y0 is equals to m in bracket x minus x0. Now substitute the values. Okay. Y minus y0. What is the y0? It is a 3. Slope is minus 4 in bracket x minus in bracket minus 2, because x coordinate is a minus 2. Here I will write here minus sign, bracket complete, and here you will get y minus 3 minus 4, and simplify this minus and minus, that will become plus. Okay, again the simplification, y minus 3 minus 4x minus 4 into plus 2, that is a minus 8, and therefore the equation of the line, that is a minus 4x minus 8 plus 3, and hence the equation is a y is equals to minus 4x minus 5, and hence I will write its equation y is equals to minus 4x and minus 5. Okay, now you can see this here. Substitute the values. Y coordinate is a 3, x is minus 2, slope is minus 4, y minus 3 is equals to minus 4 in bracket x plus 2. Simplification, minus 4x minus 8, y is equals to minus 4x minus 8 plus 3 minus 5, and hence the equation of line. Now the next form, 2-point form. It means that we know the 2 points of that line. Okay, and then we can find out the equation of a line. Let the line L passes through two given points. And what are that points? The first point P, P1, X1, Y1. Okay. Second point is P2, X2, Y2. Okay. Now see this figure. This is the line L. P1 and P2, these are the 2 points. Okay. Let PXY be a general point. Okay. This is the general point on that line L. Now these 3 points are collinear, and we know that when the 3 points are collinear, the slope of P1P is equals to slope of P and P2. Okay, or the slope of P1, P2. And here we have here the 3 points P1, P2 and P are collinear, and therefore we have the slope. What is that? The slope of P1P is equals to slope of P1, P2. You take any slope, that is a P1P, P1, P2 or P1, P2. Okay, and here the slope of P1, again y minus y1 upon x minus x1, and when we find out the slope of P1, P2, we will get the number. Okay, x1, y1 and x2, y2 are the given points. We know the values of x1, y1 and x2, y2, and that's why we are taking the slope of P1, P2. What is that? Again the difference of y coordinate upon difference of x coordinate. Y2 minus y1 upon x2 minus x1. Okay, then shift this quantity, that is keep this as it is. Shift this x1 minus x2 to on this side, to the right hand side. Then it will become y minus y1 is equals to y2 minus y1 upon x2 minus x1 into x minus x1. But what does this mean? This is nothing but the slope. Okay, and it is treated as m. Okay, therefore whenever we want to find out the equation of a line and we know the 2 points, then first of all find out the slope of the line, and then write here y minus y1 is equals to m times x minus x1. This is also method. You take any points. You can take x1, y1 or the x2, y2. But what first you have to do? You find out the slope of the line first, Then apply the equation y minus y1 is equals to m in bracket x minus x1 or y minus y2, or you can write here y minus y2 m in bracket x minus x2. That you can pass that line with x2 y2, or you can take x1 y1. Okay, what you have to do first you have to do, then find out the slope of the line. Now the next, thus the equation of the line passing through the points x1 y1 and x2 y2 is given by y minus y1 is equals to y2 minus y1 upon x2 minus x1 into x minus x1. Okay, now the next, there is a problem. Write the equation of the line through the points 1 minus 1 3 5. Okay, now here we treat as the first point is x1 y1 x2 and y2. Substitute the values. Y minus, we change the here, y minus y1, y1 is minus 1, and here y2 minus y1, y2 is 5 minus in bracket minus 1. This divided by x2, x2 is 3 minus x1, which is the 1, and in bracket x minus x1. What is x1 is 1. Now simplify here. Y minus and minus, that will become plus, that's equals to this minus and minus, it will become plus 5 plus 1 upon 2 in bracket x minus 1. Okay, and then simplify. Y plus 1 is equals to 6 upon 2, then here you will get 3 in bracket x minus 1. Then what about it's a simplification. Y is equals to 3 into 1, 3 into x, that will become 3x, and here minus 3, and when we transfer this plus 1, it will become minus, and therefore the equation of the line, that is equals to y is equals to 3x minus 4. Okay, this is the equation of the line with the help of the slope point, that is when we know the 2-point form. It's not the slope, it is a 2-point form. Instead of this doing, you can find out the slope of the line. Okay, then what is the slope? This is the slope, which is the m is equals to 3. Take any one points. Suppose I take the 1 and minus 1, then what will be the equation of the line? Y minus in bracket minus 1 is equals to 3 in bracket x minus 1, and their simplification, y plus 1 is equals to 3 x minus 3. Therefore y is equals to 3x minus 3 minus 1 is equals to 3x minus 4, and therefore y is equals to 3x minus 4. We have the same equation. If we take the point 3 and 5, okay, now see this here. Y, if I take the point 3 and 5, we have the same type of the equation. Y minus y1 means y minus 5. The slope m is 3 in bracket again x minus 3. Then what you will get here? Y minus 5 multiplication, the 3x, 3 into 3, it's a minus 9. Okay, therefore y is equals to 3x minus 9 plus 5. Therefore y is equals to 3x minus 4. Okay, all these equations are the same. Okay, whenever we know the 2 points, you can find out the slope and pass that line any one points, x1 y1 or x2 y2, or apply this 2-point form. Now the next, slope intercept form. It means that in this equation of a line, we have the slope, which is the m, and we must know it's a intercept. That intercept will be x-intercept or the y-intercept. In this figure, the line L touches the y-axis at the point 0C. It has a slope m. Okay. Then the form of the slope intercept form is a y is equals to mx plus c. It means that if you know the any point on that line and it's a slope, then its equation is nothing but y minus, this is the x1 and y1. Okay, x1, y1, we can apply their slope point form also. Here y minus y1 is equals to m in bracket x minus x1. Now substitute the value of x1 is 0 and y1 is c. Therefore y minus c, slope is m, keep it as it is. The value of x1 is a 0. Okay, and therefore y minus c is equals to mx, and here is a 0. Therefore its equation is a y is equals to mx plus c. The same form is here, y is equals to mx plus c. Here if you know directly the slope and it's a y-intercept, then you can write directly the values of m and c. You will get the equation of a line. Now this line intersect the y-axis here, that is the y-intercept, and suppose that if you know the slope of a line and the x-intercept, see this figure. Okay, I can draw these are the coordinate axes. Here the line intersect, this is the line, it intersect the x-axis. Okay, and the point of intersection, suppose that it is a d comma 0. Slope of the line, we know the slope of a line and the point or x-intercept. Okay, then what will that equation? The equation we can write it like this, that is, we know the point on the line, we know the slope, we can find the equation of a line. Y minus y1 is equals to m in bracket x minus x1. You can find out it like this. What is the value of y? Y1 is 0. Okay, this is the x1 and y1 is 0. M, okay, the slope is m, keep it as it is, and in bracket, what is that? X, the x1 is a d, therefore y is equals to m in bracket x minus t. This is the equation of a line where we have given the x-intercept and the slope of a line. Okay, this is the second case. This is the first case. When a line, we have given the y-intercept and the slope, you can have the direct this formula, and whenever you have given the x-intercept and the slope, you can substitute the values in this equation. Okay, now the next is a write the equation of the line for which tan theta is equals to 1 upon 2, where theta is the inclination of the line and y-intercept is a minus 3 by 2. Here we know that the m is equals to, that is a slope of line is nothing but the tan of theta, that is the tan of inclination, whatever that. Therefore tan theta is equals to 1 upon 2. And here we know the y-intercept. Okay, this is the y-intercept and the slope of the line. Therefore, its equation is y is equals to mx plus c in this form. Substitute the values. Okay. What is the value of m? M is equals to minus 3 by 2 x. The value of c is 1 upon 2. And then simplify. You can simplify this also. Multiply on both sides by 2. Then here you will get 2y is equals to minus 3x plus 1. And this is nothing but 3x plus 2y, and that's equals to 1. Okay. Now the next is then we know the y, that is when we know the slope and y-intercept. Okay. Now the next. Again, write the equation of the lines for which tan theta is 1 upon 2. Theta is the inclination. Now here we have given the x-intercept. Again, substitute the value. M is equals to tan theta is equals to 1 upon 2. That is, you know the slope of a line, and y-intercept, that is the value of d. D is equals to 4. Substitute the values. Therefore, y is equals to slope is 1 upon 2 in bracket x minus 4. Simplify this. That is equals to 2y is equals to x minus 4. And again, this can be written as x minus 2y is equals to 4. X minus 2y is equals to 4. Therefore, I can write this equation in this form. X minus 2y, and that's equals to 4. Okay. You can check this. X-intercept, substitute the value. Simplification. X minus 2y is equals to 4 when it intercepts x-axis. Now the next, intercept form, that is here the double intercept. Now the next type of equation is a double intercept form. Here the line L intersect x-axis at the point A 0. Therefore, its x-intercept is A. The line that L intersect y-axis 0b. Therefore, its y-intercept is a b. Now, what will that equation of that line? Now we know here the 2 points of that line. You can find out the slope of a line. Which are the 2 points? The 0, b, second point, and another point is a 0. It means that we know the 2 points of that line. You can find out the slope. These are x1, y1, x2, and y2. Find out the slope of a line. M is equals to y2 minus y1 upon x2 minus x1. Substitute the value. 0 minus b upon a minus 0, and that's equals to minus b upon a. Therefore, m is equals to minus b upon a. Now the equation of a line, we can write it like this. Y minus y1 is equals to m in bracket x minus x1, or y minus y1 is y2 is equals to m in bracket x minus x2. Okay. Now substitute the value. Y minus y1 is b, y minus b, slope is minus b upon a in bracket x minus 0. Okay. Therefore, transfer this a to the left hand side. It will become multiplied. That is a in bracket y minus b is equals to minus bx. Okay. Now the simplification here, ay minus ab plus bx, and that's equals to 0. Now see this here, the simplification. Okay, the simplification is a bx. Okay, I will write here first term here, bx plus ay is equals to ab. Now divide on both sides by ab. Divide on both sides by ab. Here you will get bx plus ay is divided by ab is equals to ab upon ab. Okay, therefore here you will get bx upon ab plus ay upon ab. Okay, ab upon ab, that is 1. Here bb will get cancelled, and therefore you will get x upon a plus y upon b is equals to 1. This is the equation of a line having the two intercept. X-intercept is a and y-intercept is a b. Okay. You can also take the point x2, y2 till you will get the same equation. Now next, find the equation of the line which makes minus 3, 2 on x and y intercept respectively. Now the solution. Here x-intercept is equals to a equal to minus 3, y-intercept is equals to b equals to 2. Equation of a line equation of line is x upon a plus y upon b is equals to 1. Now substitute the value x upon minus 3 plus y upon 2 is equals to 1. Now the cross multiplication, you can multiply like this, that is or keep it as it is, minus x upon 3 plus y upon 2 is equals to 1, or you can simplify like this, minus 2x plus 3y upon 2 into 3, which is 6, is equals to 1, and therefore minus 2x plus 3y, 6 into 2, sorry 6 into 1, here you will get 6, minus 2x plus 3y is equals to 6. This is the equation of a line having the intercept x-intercept minus 3 and y-intercept is 2. Okay. Now the next form is the normal form. Next form is a normal form. Suppose a non-vertical line is known to us with the following data. What are that? Length of perpendicular from origin to the line, means this is length of perpendicular from the origin to the line, means what? OA. Here is also OA and OA and the OA. This is the first. Next, angle with the normal makes with the positive direction of the x-axis. That is this normal that makes the angle omega in a positive direction of the x-axis. If we know these two, then we can find out the equation of a line. Here, let L be the line whose perpendicular distance from the origin OA is equals to P, and the angle between the positive x-axis and OA be omega. The possible positions of the line L in the Cartesian plane is shown in the figure. These are the possibilities in first quadrant, second, third, and the fourth. Okay. In the Cartesian plane as shown in the figure. Now our purpose is to find the slope of line L and point on it so that we can find out the equation of that line. Draw the perpendicular AM on the x-axis. The perpendicular on the x-axis. In each case, here we have the perpendicular here, perpendicular AM and the perpendicular AM on the x-axis. Now here, in each case, we have OM is equals to, now if you consider here OM, and I want to find out this distance, then I must take the cos ratio. What about here? Cos of omega for the first figure. Cos of omega is equals to OM upon OA. OM upon OA. OM is x distance and OA is the P. And therefore, x is equals to P cos of omega. Okay. This is the P cos of omega. So that the coordinate of A, that is we can find out AM also. Then how to find out the AM? For that we will take the sine ratio. The sine of omega is equals to AM upon OA. Okay. AM is the y distance. Okay. Therefore it is a y. OA is a P, that is equals to sine of omega, and therefore y is equals to P sine of omega. Okay. In this way, the coordinate of the point A is a P cos omega and P sine omega. Further, the line L is a perpendicular to OA. This OA is a perpendicular to line L. Therefore, the slope of the line L is equals to minus 1 upon slope of OA. Okay. And that is equals to minus tan of omega, and that is equals to minus cos of omega upon sine of omega. Thus, the line L has a slope minus cos omega upon sine omega, and the point is A, P cos omega, P sine omega on it. It means that we know the point on that line, and also it's a slope minus cos omega upon sine omega. We can find out the equation of this line L now by using the slope point form, that is a y minus y1 is equals to m in bracket x minus x1. Substitute the values. Okay. and then simplify. What is the simplification? Sine of omega here in bracket y minus p sine of omega, and that is equals to minus cos of omega in bracket x minus p cos of omega, and the simplification y sine omega minus p sine square omega here minus x cos omega and plus p cos square omega. If we transfer this minus x cos omega here plus y sin omega and transfer this here and take the p as a common, sin square omega plus cos square omega, that is 1, and therefore here the equation of the line in the normal form x cos omega plus y sin omega, that's equals to p. This is the standard form. X cos omega plus y sin omega is equals to p. This equation of the line, it is called the normal form. If you know this p and the omega, we can find out the equation of the line. Now the next example. Now the example number 11. This example depends on the normal form x cos omega plus y sin omega is equals to p. Now see this here. Find the equation of the line whose perpendicular distance from the origin is 4 unit and the angle which normal makes with the positive direction of x-axis is 15 degree. Here we have p is equals to 4 and omega is equals to 15. But how to find the value of cos of 15? And I can write it is like this. That is, the cos of 15 means what? Cos of 45 minus 30. Okay. Cos 30. Cos of 45 minus cos 30, that is cos 15. Now the expansion of cos of a minus b, which is a cos of 45 into cos of 30 plus sine of 45 into sine of 30, and this equals to cos 45 means 1 upon root 2. Okay, and cos 30 is root 3 upon 2 plus sine 45 is 1 upon root 2 and sine of 30 is equals to 1 upon 2, and here the multiplication 1 into root 3, this is the root 3 upon, okay, 2 root 2 plus 1 upon 2 root 2, okay, and that's equals to root 3 plus 1 upon 2 root 2. And similarly, you can find out the value of sine of 15 also. And this is the easiest way. Again, sine of 45 minus sine 30 and its expansion. Sine of a minus b means what? Sine of 45 into cos of 30 minus sine 30 into cos of 45. Okay, sine 45 is 1 by root 2. Okay, cos 30 is root 3 upon 2 minus sine 30 is again 1 upon 2, cos 45 1 by root 2, and overall here if it multiplied 1 into root 3, denominator base is same for both of them, and here 1 into 1 minus 1, and here you will get 2 root 2. Therefore the value of sine 15 is root 3 minus 1 upon 2 root 2, and you can substitute the values here. Okay, And next, both of them have the same base. The multiplication root 3 plus 1 upon x plus root 3 minus 1 into y into 4 into 2 root 2. If we take the cross multiplication, 4 into 2 root 2, and that is equals to 8 root 2, and this is the required equation. Now the next example is the Fahrenheit temperature F and the absolute temperature K satisfy a linear equation. Here K is equals to 273, F is 32. Again K is equals to 373 when F is 210. Express K in terms of F. Find the value of F when K is 0. Okay, no problem. Assuming that F along the x-axis, Y. Now see this here. We can draw a picture. Okay. The F. Okay, F along the x-axis and K along the y-axis. Okay. We know these 2 points, 32 and 373, and here 212, 373. Now by using the 2-point form, what is that? Here the coordinates are x1, y1, x2 and y2. Substitute the value. What is that? Y minus y1 is equals to y2 minus y1 upon x2 minus x1. Okay. And you have this k minus y1, that is a 273, and here is the slope, difference of y coordinate upon difference of x coordinate. After simplification you will get k minus 273 upon 100 upon 180 in bracket. What is here? The again, sorry, one more multiplication in bracket. Here the equation of the line is x minus x1, and again into here x minus x1, that is a 32. Okay, substitute the value, and next 373 minus 273, 100, and here 212 minus 32, you will get 180. Okay, and next if we divide it, you will get, simplify it, 5 upon 9. Okay, therefore transfer this 273 to this right hand side. Therefore k is equals to 5 by 9 in bracket F minus 32 plus 273. This is relation between the Kelvin and the Fahrenheit, or K and F. When k is equals to 0, substitute value k is equals to 0, 5 by 9 in bracket here minus 32 plus 273. Minus 273 is equals to 5 by 9 in bracket k minus 32, and here F minus 32 is equals to 273 into 9 upon 5, and if we simplify it, we will get 491.4, and hence the again F is equals to minus 491.4 plus 32, you will get my F is equals to minus 459.4. Okay. And in this way we can calculate the value of k and also the relation between the k and f. And in this way we have completed the first part of the exercise 10.2, and the next video will be the exercise 10.2. I will explain full exercise in that my video. Now we'll see in the next video. Till then, goodbye.